All right, quarter 2, week 8, day 4. Find the quotient. All right, how many times does 23 go into 1? It cannot. How many times does 23 go into 14? It can't do that either. How about 23 into 141? Yeah, that would probably be about 6 times. 6 times 3 is 18. 6 times 2 is 12, plus 1 more is 13. And let's subtract. Well, we're going to have to borrow from this 4 and make it a 3, and that is an 11. So 11 minus 8 is 3. 3 minus 3 is 0. 1 minus, okay, so that's all we have for that one. Now let's bring down the 4. How many times does 23 go into 34? Well, 2 times would be 46. That's too many, so just 1. 1 times 23 is 23. Okay, 4 minus 3 is 1. 3 minus 2 is 1. Bring down the 5. All right, let's see. Let's actually make that a 1. Okay, so how many times would 23 go into 115? Well, I know 23 is close to 25. 4 of those would be 100. 115. Let's go ahead and make it 5 of them. 5 23s. Let's see what happens. 5 times 3 is 15. 5 times 2 is 10, plus 1 more is 11. Well, that worked out perfect, okay, which gives us no remainder. So the answer to this one is 615, or 615, not 615. But 615 is the answer to this quotient, or to this problem. All right, we're going to find the quotient again. Okay, but this time we have numbers that have decimals, and we do not want to have decimals in the divisor. Okay, so I moved it over 2 places, and that's what goes here. And then I moved it over 2 places. So we have 21.24000. I just added the zeros because I never know. So I just do that anyway. How many times does 6 go into 2? It cannot. How many times does 6 go into 21? Well, 4 times would be 24, so we're going to have to say 3, I guess. 6 times 3 is 18. 21 minus 18 is 3, right? And then bring down the 2. How many times does 6 go into 32? Let's see, 6 times 6 is 36, so 6 times 5 would probably have to be what we go with. 6 times 5 is 30. 32 minus 30 is 2. Bring down a 4. Ah, perfect. 6 times what will give you 24? Or how many times does 6 go into 24? 4 times. 6 times 4 is 24. We don't have a remainder, so we're done right there. We just bring the decimal up, so the answer is 3.54. All right, so if you divide those two numbers, you get 3.54, and that's our answer for that problem. A party store sells large plates in packs of 12, okay, and small plates in packs of 8. If you would like to have an equal number of both, what is the least amount of large plates you will have to buy? Okay, so if we look at this, we can get small plates in certain packs, okay, and so the small plates, we would look to see what is the least amount that you could buy that would end up being in both. Well, I guess if we got 8 at a time, we can get 23 of those and get 24 small plates. And then for the large plates, we can just buy 2 packages and get 24 large plates. So that way we would have the exact same number of large and small plates, so we would not have any left over. So the answer here would be 24. All right, that's the answer for that problem. There are 28 students in math class. 22 of them passed the test. Okay, so we have 28 total students. 22 of them passed, which means 6 didn't pass. What percentage passed the test? Okay, so we know to get percent, we have to take the total and divide it into the part. Okay, so we're going to do that. So 28 goes into 22.000. Okay, I always do plenty of those, so there we go. All right, so let's look at this. How many times does 28 go into 2? It can't. Can 28 go into 22? No. Can 28 go into 220? Yes, I think it will. And I'm pretty sure, let's try 7 first and see if that works. 7 times 8 is 56. Okay, and then we have 7 times 2, which is 14, plus 5 more is 19. Okay, let's see if we end up with less than 28 when we subtract. So we're going to have to borrow from this 2 and make it a 1 to make this big enough. 10 minus 6 is 4. Now we're going to have to borrow from this 2 and make it a 1, make this 11. So that's 2. So 24 is less than 28, so we're good with that. Let's bring down the 0. Okay, so then how many times will 28 go into 240? I think it'll probably be one more than 7 this time. I think we're going to go with 8. 8 times 8 is 64. 8 times 2 is 16 plus 6. So 16 plus 6 equals 22. So then we're now going to subtract 4 from 0. Can't do it, so we're going to have to borrow. Okay, this becomes a 10. 10 minus 4 is 6. 3 minus 2 is 1. And then bring down the next 0, 160. So how many times would it go into that? I'm thinking we're going to have to be probably around 6 on this one. We'll see. 6 times 8 is 48. This has to be a 4 here. 6 times 2 is 12. Plus 4 more is 16. It's actually going to be too high, isn't it? It's 12, 16. So it's going to be a 5, probably. Okay. And then, let's see if we do that. 5 times 8 is 40. 5 times 2 is 10 plus 14. So, there'd be a 0, a 2. Yeah. And then we bring down another 0. Okay, and then we kind of keep going from there. So, all right, so that's where we have. We have that it's 0.785. Okay, and then we know at this point we have the decimal. We have to turn it into a percent by multiplying it by 100. Okay, so all we would do is move the decimal over 2 places. So it's going to be 78.5. Okay, it actually might be 78.6 depending on what this next number is. We might have to round it, but we'll just leave it at that. 78.5%. Okay, so 78.5%. So 22 out of 28 is 78.5%. All right. Simplify the expression. So we are going to be looking for like terms. Okay, so let's look at this one. We have a 7y. Are there any other y's in this? Yep, there is a negative 2y. Okay, so we have a 7y and a negative 2y. So it's 7 minus 2, which is 5. So we have 5y. And that takes care of that and that. Okay, so then we have a 3x. Are there any other x's? Nope. So we can just leave that 3x. And then we have a 3 and a 6. Those are both constants, okay, because they have no variable with them. So 3 plus 6 is 9. So we simplify the expression. We have 5y plus 3x plus 9. And they can actually be in any order, okay, but those are the 3 terms. 5y, 3x, and 9. Just to remind you, this letter, or this number next to a letter, is a coefficient. This is called a variable, okay? And each one of these are called terms, okay? So there we go. And then this one is called a constant. All right, so let's move on to the next one. Actually, we're going to finish this one real quick. What is the coefficient of y? Well, it's the number right next to the y. What is the constant in this situation? That is the 9. Now we are finished with this one, and we're moving on to the next one. Are the two expressions equivalent when x equals 5? Okay. Well, let's just make life easier by combining these like terms. We have a 7x and a 3x, so that's actually just 10x. right? So that's going to be pretty easy to utilize later on. And then we have a 9x plus 5 here. So let's just kind of get rid of this one. We'll go ahead and plug in 5 for x there. So what is 10 times 5? 10 times 5 is 50. Okay, so then we'll put in 5 right there. So we have 9 times 5 is 45. And then once we have that, we're going to add the 5 to that. Okay, so 45 plus 5. And that equals 50. All right, so if we put in x for each one of these, are they both going to be the same answer? The answer is yes. Okay, that's the answer for that one. It takes Johnny 42 minutes to get to the zoo. All right, and then after 18 minutes, he stopped for gas. Okay, so 18 minutes into the trip, stopped for gas. He's got the rest of the 42 minutes to go until he gets there. Write an equation to express how many more minutes he has to travel. Okay, well, we know the total minutes traveled is 42. So again, that's what we do as our answer, our equal sign. And then he's gone 18 minutes so far. And then he has to go the rest of the way. So we can pick anything at all. How about n? I don't even know why, but 18n. We're not going to multiply times n. We're going to add n. So 18 plus the rest of the miles that he's going to travel equals 42. So we don't really have to solve it. We just need to make the equation. So there it is. 18 plus some variable, doesn't have to be n, equals 42. That would be our equation. All right, let's go on to the next one. All right, we have all kinds of room to solve for x. Well, what do we have to do when we have a number next to our variable? We have to get rid of that number. We have to get the variable by itself. So we have 8x, which is times. So we're going to divide both sides by 8. Okay, 8 goes into 8 once. So on this side of the equal sign, we just have 1x. And then on the other side, we have 144 divided by 8. And that is 18. So 18 equals x, or x equals 18. I prefer to always have the variable first. Okay, so to solve for x, the answer is 18. And we know that because if we do 18 times 8, we'll get 144. All right, and that's the answer. That's all we have to do for that one. Every night, Nathan has to read at least 25 minutes. Okay, every single night, 25 minutes or more. Write an inequality that shows how long Nathan can read each night. Okay, well, we know that we have a 25, right? And I like to put the variable over here on the left side. So Nathan reads 25 minutes. Can he read exactly 25 minutes? Every night, Nathan has to read at least 25 minutes. So he can read exactly 25 minutes, right? So if that's the case, we have this greater than, less than possibility, greater than or equal to, or less than and equal to. Okay, they're all kind of blending together there. So, but those are our options. So we can do exactly 25 minutes. So it's going to be one of these where it's going to be greater than or equal to or less than or equal to. So I'm going to put the little line underneath it. And then Nathan can read at least 25 minutes. Can he read 26 minutes or 27? Yes, he can read more than 25 minutes, but he can't read less than that. So x has to be greater than or equal to 25. There's our inequality. All right, that's all we have for today.